black holes have captivated our imagination for decades, but what exactly are they? Chapter 1. What is a black hole, really? Contrary to popular belief, a black hole isn't actually a hole at all. It's a region in space where gravity is so intense that it crushes matter into an infinitely dense point called a singularity. Once you cross its boundary, known as the event horizon, there's no turning back. To understand black holes, we need to grasp a few key concepts. The singularity is the core of the black hole, where all the mass is concentrated. The event horizon is the point of no return. Once you cross it, not even light can escape. This is because the escape velocity, the speed needed to break free from the black hole's gravitational pull, exceeds the speed of light itself. Recent research from Science News Today has shown that gravity doesn't just affect matter, it warps the very fabric of space and time beyond the event horizon. This distortion becomes more extreme the closer you get to the singularity, leading to some mind-bending effects we'll explore later. Chapter 2. Types of black holes. Not all black holes are created equal. In fact, they come in a variety of sizes and types. Some are relatively small, about the size of a city, while others are so massive they can swallow entire galaxies. The main categories are stellar black holes, supermassive black holes, intermediate black holes, and the theoretical primordial black holes. Stellar black holes form when massive stars collapse at the end of their lives. They're typically a few to several tens of times the mass of our Sun. Supermassive black holes, on the other hand, are the giants of the cosmos. They reside at the centers of most galaxies, including our own Milky Way, and can be millions or even billions of times more massive than the Sun. Interestingly, Astronomy.com reports that supermassive black holes like Sagittarius A*, the one at the center of our galaxy, may allow for brief survival past the event horizon due to their enormous size. This is in stark contrast to smaller black holes, where the effects of gravity become lethal much more quickly. Chapter 3. Approaching the event horizon. As you approach a black hole, the laws of physics as we know them begin to break down. Time slows down dramatically, a phenomenon known as time dilation. Light bends in ways we can barely comprehend, creating stunning visual distortions. And the very structure of space becomes warped and twisted. One of the most fascinating effects is gravitational redshift. As light struggles to escape the intense gravitational field of a black hole, it loses energy. This causes the light to shift towards the red end of the spectrum, hence the term redshift. The closer you get to the event horizon, the more pronounced this effect becomes. Chapter 4. Spaghettification and survival scenarios. Psych Daily reports that your chances of survival depend greatly on the type and size of the black hole you're approaching. For a stellar black hole, the outlook is grim. You'd experience a process colorfully known as spaghettification. The difference in gravitational force between your head and feet would become so extreme that you'd be stretched out like a piece of cosmic spaghetti, torn apart molecule by molecule. However, in a supermassive black hole, things might be different. Science News Today explains that these behemoths have much gentler gravitational gradients due to their enormous size. This means you might not even notice when you cross the event horizon. The tidal forces would be less extreme, potentially allowing you to survive. At least for a while. Chapter 5. Inside the Singularity, Speculation and Theory. But what lies beyond the event horizon? This is where we enter the realm of speculation and theory. Some scientists propose that a black hole could be a cosmic trash compactor, crushing everything into an unimaginably dense point. Others suggest it might be a portal to another universe or a different part of our own universe. The concept of wormholes, theoretic tunnels through spacetime, is often associated with black holes. While purely theoretical at this point, the idea has captured the imagination of scientists and science fiction writers alike. Another intriguing concept is quantum gravity, which attempts to reconcile quantum mechanics with Einstein's theory of general relativity. There's also the firewall paradox, a theoretical conflict between fundamental principles of physics that arises when considering the behavior of an observer falling into a black hole. These ideas push the boundaries of our understanding and highlight how much we still have to learn about these cosmic enigmas. Chapter 6: Could we ever escape? NASA science emphasizes that while black holes distort space and time in extreme ways, one thing remains certain: once inside the event horizon, nothing escapes. The gravitational pull is simply too strong for any known force or particle to overcome. So, could we ever escape a black hole? The short answer is no. Once you're past the event horizon, there's no turning back. Even the most advanced spacecraft we can imagine would be helpless against the overwhelming gravitational force. However, there is a glimmer of hope for black holes themselves. Stephen Hawking proposed that black holes aren't entirely black. They emit a faint glow of radiation, now known as Hawking radiation. Over an unimaginably long time, this radiation could cause a black hole to evaporate and disappear. But don't hold your breath. For a black hole the mass of our Sun, this process would take longer than the current age of the universe. While escaping a black hole might be impossible, understanding them could unlock some of the deepest secrets of the universe. These cosmic monsters push the limits of our knowledge, forcing us to reconsider our most fundamental theories about space, time, and the nature of reality itself. As we continue to study black holes, we're likely to uncover even more mind-bending phenomena. From gravitational waves to the possibility of microscopic black holes, these enigmatic objects continue to surprise and challenge us. They represent the frontier of our understanding, the place where the known laws of physics break down and new discoveries await. In the end, while we can't survive a black hole, we can certainly learn from them. They offer a unique laboratory for testing our most advanced theories and pushing the boundaries of human knowledge. As we peer into these cosmic abysses, we're not just exploring the universe, we're exploring the very limits of science itself. So, the next time you gaze up at the night sky, remember that out there, scattered among the stars, are objects so powerful they can bend light, warp time, and challenge our understanding of reality. Black holes may be the ultimate cosmic mystery, but with each new discovery, we inch closer to unraveling their secrets. Thank you for watching.